And yep, so this is the July 11th meeting of the Resource Management Work Group. Got 2 topics on the agenda today. So Deepak and Rohit, the floor is yours.
Rohit, do you want to go ahead and share your screen?
Hi everyone, are you able to see my screen?
Yeah, we can see.
Okay, I'll be presenting the resource over subscription work that we did at Huawei. So as we know, like resource subscription is something like we have primary and best effort jobs which need to be co-located on the same machine, and how can we best utilize the resources by sharing them across both the category of applications without affecting the SLAs of primary applications. So we have tried to address this concern by introducing some logic within different components in the Kubernetes system. So this is the overall architecture diagram that we have. So we have the slave node where the kubelet runs, and we have the master node where the scheduler, the API server runs. So we introduced 2 new components within the kubelet. Currently, they are a part of the kubelet code. They are essentially Go routines that run, and one of them is called as a resource estimator. So the purpose of the estimator is to report back what are the available and reclaimable resources. So I will touch upon what do I mean by reclaimable resources as we move ahead in the slides. So this guy tries to estimate what are the available and reclaimable resources by updating the node status of every node by doing this API call to API server. So the second step is we have added a new controller called oversubscription controller in the master, which retrieves this information from every node, which tells essentially about this information, and based on this information, every node will be tainted with a label by means of which we can enable or disable resource oversubscription feature on any node. What this will achieve is a scheduler which will try to schedule best effort pods which would like to use this reclaimable resources will be able to make decisions whether to schedule this pod which can accept reclaimable resources on a particular node or not. So a scheduler will have this information about all the different type of resources on node X, and then it will try to schedule a best effort pod onto reclaimable resources when necessary. So a best effort pod is a pod which does not require any guarantee to run. So it does not request any resource, or it does not specify any limit. So it is like it says that okay, it is okay for me to run, but I'm okay to be evicted whenever you want me to be evicted. So this scheduler
can you say that again? I want to make sure we have the same terminology and we're talking about best effort. So traditionally when I hear best effort pod, I assume a pod that makes no resource request or resource limit. It sounded like you said that you included in there also a pod that has no limit but may have a request. Am I mistaken that?
No. It will typically not either specify a request nor a limit. So yes, it will not have either a request or a limit. It will not have any such request in its pod spec. It will not request for anything. That's what we call a best effort pod.
Okay, I just want to make sure I didn't miss here.
How do you match the best effort job against the oversubscribed resources then? Or just feel free to say you're going to get to that later if that's in the presentation.
Yeah, he's going to get to that, yeah.
Okay.
Late. So the API server then launches the best effort pods onto the slave node, and there is another guy called QoS controller, which is another Go routine which runs every n seconds, which might be the monitoring interval, and it will monitor the resource usage of regular pods. Okay, and if we think that the resource usage is going beyond a certain threshold for a regular pod, so it might be okay to give back the resources which were taken from that regular pod, so that its SLAs are not violated. So it will try to kill a best effort pod, or it will try to freeze. So I will explain why do we need a freeze action. But in case of memory, if you want to release the resources, we'll typically kill a best effort pod so that the memory is given back to the regular pods. So this is the overall interaction diagram that we have. So I will go into the details of each of these components in the later slides. So this is the scheduling example. So if you see the state A, you have two pods which are running, okay, pod 1 and pod 2. So what we have is typically three sections here. The used resources is the so say a guaranteed pod requested for some X amount of CPU. So it might not be using the whole X amount of CPU. It might be using X by 2 or X by 3 amount of CPU. So and we also have some headroom which we use for some buffer, right? And so whatever is left is what we call as reclaimable. So this reclaimable resource can typically be shared by some other best effort pod to run. And similarly, there is another pod, pod 2, which will again have a similar structure like this. So if you see this blue section which is highlighted here, this is the total reclaimable resources that is available across pod 1 and pod 2, which can be used or it can be shared by some other best effort pod to run. Okay, so yeah. So if a best effort pod, say pod 3, wants to be scheduled, and it is okay, it tells that it's okay to use this reclaimable resources. So it gets scheduled onto this node, and the state C shows that okay, this particular block is now replaced by a pod 3, which is having some headroom for itself, and this was the original available resources that it had. Okay, so this is the kind of resource allocation or changes in the resource allocation that will happen when a best effort pod is okay to accept reclaimable resources. So the next slide talks about pod eviction. So now assuming that the pod P2's usage increases, and we think that whatever resources were taken back from pod 2 have to be given back. So in that case, this whole pod 3 will have to be evicted or taken out, so that these resources are given back to pod 2. So this figure depicts how do we do eviction for best effort pods in case the pod the primary pod's usage increases beyond some threshold.
So one thing that I'm curious about is,
Yeah.
obviously today in the kubelet we have some support for evicting pods when memory usage is, when available memory runs scarce on the node. Like, is there a reason why we couldn't make the kubelet itself just more potentially more intelligent about how often or when it makes that eviction decision versus having to have this external pods controller do it? Like,
yeah, so our work was inspired from Heracle's paper from Christos and team, and also a project called Mesos Serenity. So in Mesos also they have a project called Serenity where they have actually developed this controller pipeline kind of a thing, which I'll describe later, where you have pluggable controllers for different types of resources, and each controller will actually try to monitor that particular resource, and then it will try to take some action. So we took inspiration from that design, and we thought we could come up with a similar framework in Kubernetes. So
but just
that's why we went
this is,
for a separate controller.
When you refer, and I'm sorry, but I guess when I think about pod eviction, I think about today what we have in the kubelet, which is evicting pods to keep the nodes stable when resources run scarce. While as the picture as presented here is talking about how do I make room for scheduling new pods, or how do it's less focused on how do I keep the node itself stable. I guess what I'm trying to do is, like, distinguish this type of eviction versus the eviction we have today.
So Derek, I could also talk to it. So we actually developed Serenity and got the APIs into Mesos, which a lot of these concepts are derived from. And controllers are very similar to the eviction manager. And just in Heracles, there's more than one. So there are controllers for each resource vector that you want to protect. For example, for cache, for power, for networking. And those are all things that could probably go into the kubelet eventually, right? So you ensure headroom, egress for high-priority containers, guaranteed or best effort. The resource estimator basically was a soft measure for how many best effort pods that could be allowed into the machine, right? So I guess that number could also be estimated by the eviction manager, right? It can reduce that to 0 and say no more best effort stuff, right? Through the node condition.
Wait, how would this be different in the scheduler where I have to look at node usage and then restrict new best effort pods?
So it's mostly to have a local agent kind of deem how many, right? I guess just like I'm kind of deriving in the abstract here. So a resource estimator would basically be, so help me if I don't know the most recent details on the resource estimator or the eviction manager, but can the eviction manager give a count of how many best effort pods that could be allowed to be admitted?
No, so there is no such concept. The thing is, like, you don't know how much each best effort pod is going to take up. There is a global limit on the number of pods in the node. And so the combination of like a bunch of other API constructs, it could like infinitely restrict the number of best effort pods. But the thing is, it's like you don't really know how much they're going to use, right? Like they're scavengers, and they might be very like used opportunistically. And so one of the things that we have talked in the past that we unfortunately haven't implemented yet is having the scheduler be aware of node usage and do best effort scheduling for best effort pods.
So I'll touch upon the scheduler and resource estimator maybe in the later slides, which might help clarify a bit more.
Yeah. The only other comment I would have here is I'm also reminded of some work that Seth did either a release or 2 releases back where you could reserve resource across clause tiers. And I'm just wondering if this is also potentially solving a similar need. But yeah, I kind of am like Fish where I feel like this appears to be how do I could move a best effort pod to a node that's least utilized first by having that utilization aware knowledge when doing the scheduling of just best effort pod.
Just a quick comment. This is Deepak Vej from Huawei. So this POC effort we did was around 6 or 7 months ago. So I mean, after that, there's been a lot of work done. So that's one of the things we wanted to kind of find out as well. Kind of reach out to you folks and the scheduling sig folks. Where is the overlap and what can we do? I mean, as far as the work which we have done, how does it kind of work side by side with the estimator manager, the estimation manager, and the component which you folks have developed. So that's kind of just to kind of give you a summary as well. So this work was done about 6 or 7 months ago. So I know that a lot of work has gone on. So that's why we wanted to kind of just if you don't mind, let Rohit present it, and then we can have a follow-on kind of discussion. Where is the overlap and all those kind of things. Is that okay?
Yeah, that's perfect. All to say in terms of like terminology, we use preemptions to refer to actions that will like evict or like that will like basically disrupt pods for reasons other than say resource starvation on all across the node. So there's evictions and there's preemptions. Maybe if you want to avoid confusion with evictions, you could in theory use the term preemptions.
So there's another note about the original paper and also the Serenity work was that eviction looks a lot like the eviction manager, but really that was kind of the most drastic the term that we used before was called corrections. And the idea was, if you realize through the high priority APMs that the application that you care about is suffering, then you go hurt BE. And the worst thing that you can do is kick it off the box. But if you have more granular control, then the first thing that you would do is try to throttle it along different resource dimensions. So, just the fact that the one correction that is outlined here is eviction, it might not overlap as much with the eviction manager in later iterations as what it initially looks like. But,
and I will say that in the CPU pinning stuff, we're looking at adding, we've got the same kind of issue, right? Where basically we can allocate all the CPUs on the box to guaranteed pods. And then we actually can't satisfy best effort pods, and we need some way to signal to the scheduler to say, hey, don't schedule best effort pods to us. So it seems like there's kind of a generic need for some signal that you can, CPU pressure or best effort pressure or some node condition you can apply to let the scheduler know, hey, I know that you think that I've got room for things, but I don't.
Okay. Yeah, so we also did some stuff for network bandwidth, but I'll probably not cover it in this presentation. But just wanted to know that it was also part of Heracle's paper. So
yeah, so this was the whole. So we pretty much, as Rohit mentioned, we used the whole pipeline design. So one of the pipeline controller was the network controller and the memory controller. We didn't really do the CPU controller, but that's one of the things we did that as well. Yeah, you can keep going, Rohit.
Okay. So, so the API object changes that would be required in order to achieve this is first, say an application which doesn't want to share its resources, reclaimable resources, with any other pod would also have the capability to say so by introducing a new flag which says that offer reclaimable resource false. This would mean that that particular application would not be willing to share its reclaimable resources. So the scheduler would basically not try to schedule any pods, best effort pods, by taking away resources from this particular deployment or application. So I think we had presented this in the scheduler sig, and one point that was brought up was we could simply not take away reclaimable resources from a primary pod just like that. So it should be based on some priority or some logic. So we thought we could introduce this additional field where the user could provide some option to say that whether he is okay or not. So this is the first API change. Yeah.
Why is that the case? Why can't you, like, as long as you offer some SLA for access to resources, why can't you opportunistically overcommit that?
Yeah, so the point there which was brought up was some applications have a very, very strict latency requirement, like with maybe 2 seconds or 4 seconds. So it would be very difficult to monitor the resources and then predict and then estimate, schedule, and all that stuff within that time frame. So some applications would really be not willing to share resources for even a fraction of a time. So in those scenarios, those applications would not really be happy to share resources. So that was a discussion that went along in that sig.
Okay, so essentially it's like saying that you have a really latency sensitive application, and one of the features that application, such an application gets is that its resources will never work.
Correct. Yeah.
Sorry, go ahead.
Yeah. So the second API change would be if a best effort pod would want to accept reclaimable resources, so he would set a flag accordingly in its pod spec. So ideally, as we discussed, he would not specify any requests or limits, but he would simply say that I'm okay to accept reclaimable resources. So the scheduler would then consider this. Hello?
Aren't all best effort pods inherently accepting reclaimable resources?
Yes, they would, but we are still not sure whether if we put any requests or limits over here, or we if we omit any of those, would they be categorized as burstable?
Yes.
That's what is yeah, okay. Fine. So in this case, we could then do away with this flag, assuming that if we don't have any request limits, it is a best effort pod. Yes, correct.
Okay.
Yeah. So this was a resource estimator. So this is just a flow chart of how it operates. So it initializes with some configuration, and it does metrics acquisition, like it acquires metrics using C-advisor, and it has some smoothing and forecasting methods, and it tries to calculate basically what are the reclaimable resources that are available on this node. So ideally, it would be reporting like for that particular node, what are the amount of resources like CPU and memory that can be reclaimed. So this can also be further improved by introducing some kind of confidence level, or for how much time are we really sure that this kind of resources can be reclaimed. But we did not include that in our first pass of implementation. We just provide a static point in time calculation of the amount of reclaimable resources on a particular node. But yes, ideally this estimation could be further improved with the additional parameters. So this is just a graphical view of how do we calculate reclaimable resources. Basically, it's total requested resources by a non-best effort pod, which is like a primary guaranteed pod, minus the total actual used by that non-best effort app, and considering some buffer for the headroom, and then you subtract the requested resources by the best effort app. So this is just a pictorial representation of that. The oversubscription controller, which sits on the master, right? Its job is to basically taint a particular node based on the amount of reclaimable resource. So say if the amount of reclaimable resource is greater than some threshold, which can be configured as a startup parameter or something, then we can enable the feature on the node. So a scheduler will then be able to schedule best effort pods on the node based on this taint, if it is saying that it's enabled. And if it is less, it will do the opposite. So it will not allow any more best effort pods to be scheduled onto that node. And enabling, disabling the feature can be done by applying taints, and threshold can be passed as a parameter. So does this help clarifying how can the node be tainted, or how can a scheduler use this information?
Yeah, I'm trying to reconcile this last slide with the existing behavior you can get by setting eviction thresholds today.
Okay.
And so it feels similar. And then I guess the part that appeals to me is just being able to have the utilization aware scheduling so that I could place best effort pods to the least utilized nodes as a priority.
That Derek, sometimes the utilization that does not have a correlation with how much a workload is hurting. So it's a really complicated topic, right? And the computation we had before in terms of reclaimable resources was only in terms of CPU time. But it's, I think one of the conclusions from Heracles is really that it's hard to gauge. You have to, look at the performance, and then it's almost like, open the gauge or close it, right? But not to allow more stuff to come in.
To be honest, the thing I'm mostly wrestling with, and I wanted to finish the point on here, was like the realistic difference between a burstable pod that sets a very low request and a best effort pod is it's like a mirage. Like they're very similar, and so like I've been just sitting here thinking about like is trying to do this with the best effort clause alone, like, is that really people's problems? Like, when I think about the types of workloads that I know our users are scheduling onto, say, our OpenShift product, more often than not, people are actually setting requests and limits. It's just the shape between those two vectors is very wide. Like, there's a very huge burstable constraint. And it could be argued that their request is just so realistically low that, like, it's most by nature best effort, but we don't fully allow it to become best effort. And I guess what I'm wondering in the community is, like, how many, like, where you ran this and when you tested this, like, what were you targeting as best effort jobs, and, like, how overall utilized is your cluster?
Was it a question for Deepak, or was it a question?
I mean, it's a question for Deepak. Like, when you motivated the work, like, what were you targeting to run as best effort, and why would you choose to run at that rather than give a minimum, or say, like, a lower request value? And are you targeting resource starvation around memory or CPU for the previous question?
Rohit,
So,
you want to answer that? Yep.
when we did this work, yeah. So this was a part of our technology project actually, and we were trying to also see how we can schedule short-running jobs which require, say, very less amount of execution time, and we were trying to experiment and seeing whether we can get any good resource utilization by sharing of the resources. So we primarily targeted memory, and we also did some work on the network bandwidth, but we did not do any work on CPU. But we tried running some experiments using CPU core pinning, but that was not integrated into the code as such.
So just one more clarification. So this is not really, this is not, so I think that Derek, your question was, what exactly is your use case or a customer requirement?
Yeah, I'm trying to make it real world versus less academic. And, like,
so it is, so the scope of this effort was more like an academic kind of thing, in the sense that, we wanted to kind of use the Heracles and kind of understand, how can we implement a similar kind of thing within Kubernetes, like the Mesos folks, Nicholas and these guys did that in Serenity project. Actually. So from that perspective, so we didn't really, you can see that, we never even built the CPU controller. So the focus was more around memory and network at that time. It's not that because this is what the requirement was. This is something we did that, at that time, basically.
So what is the goal of this presentation?
What's the goal, what?
Like, what are you hoping to take away today?
So the takeaway, exactly what do we want to do with this, all this?
Yep, like the reason for you presenting here, like.
So I think so. The what we've done is, so essentially we built this whole design, the resource reclamation thing, and so obviously it's a POC effort. It's not something in production or anything like that at this stage. So we wanted to kind of reach out to community and see how do we go forward. I mean, can we kind of could this be a baseline and we can build upon it, or is there some overlap already there in the community and we can kind of work together? Because we've written a lot of code actually. So we wanted to take it further, essentially share with the community what we have done, and then go from there. Basically, that's the goal.
Okay, so I have a few thoughts, but I'll let you both complete your presentation before we get to that.
Yeah, go ahead, Rohit.
Okay. Yeah. So the next slide talks about the QoS controller pipeline, where I mentioned we have a bunch of controllers, and what essentially each controller does is it builds an action list. So an action would typically say that I want to kill a pod, or I want to freeze a pod or unfreeze a pod, and every controller takes monitors the usage of primary pods, and then builds a list of actions of secondary or best effort pods to be killed or frozen. So a networking controller would typically inspect the bandwidth, that is bandwidth usage of a primary pod, and then it would try to freeze a best effort pod if required. We did not do the shared resource CPU cache controller. And the select controller was again implemented with a custom probe agent, which would basically monitor the latency of the application and then do some actions based on that. And the action executor was the place where all the actions will be executed, like actually killing a pod or freezing or unfreezing a pod. And a corrective action was like if we later observe that the primary pods are no longer at their peak, and we can go ahead and scan whatever pods we had frozen in case of network bandwidth. We could unfreeze those so that they can start functioning and start consuming network bandwidth as they were doing previously before getting frozen. So this is the overall controller pipeline. And so the comments on the scheduler sig I have just noted them here. So one question was the kubelet should not contain the QoS controller code, and it should be designed as a daemon set pod so that we keep changes to the kubelet at minimal. This was one recommendation we got. And the second one we already talked about, that we cannot simply take away resources from primary jobs. The third one was why CPU controller was not included, because CPU is managed by the Linux kernel component C groups, and by setting CPU shares, the Kubernetes is able to arrange for the CPU resources. So we did not handle the CPU controller as such, but but we had to do some work on core pinning, which was like not completed in that time frame. And we were also asked for some statistics pre and post applying the QoS controller. So if you see on the right hand side, we have a graph which shows that. So with respect to CPU and with respect to memory, you have the data there. So this chart compares the average utilization for CPU and memory between we call it HOS, like Huawei Orchestration Scheduling System, and open source Kubernetes when they run with full load. So we did with 4 different data sets, combination of the workloads, web apps, big data jobs, and enterprise apps. And we observed the average CPU utilization with open source Kubernetes was 25%, and with our resource over subscription enabled, it increased to over 76%. And similarly, the memory utilization shot up from 31% to 84%. So these are the stats that we got. And yeah, this is some roadmap that we have tried to put, but we just want to take your thoughts on this. Like we just wanted to enable the CPU controller, also make the network bandwidth controller more mature, and improve upon its functioning, and also improve the prediction algorithms which are used for resource usage. Like we try to predict in the next 10 seconds or in the next 20 seconds what will be the resource usage for a primary pod for performing an eviction, or freezing the secondary pod, and also improve upon the resource estimation techniques that we saw earlier. So yeah, that's it. So
yeah. So I think, yeah, so just kind of recap that, Rohit, I think your question, so what exactly is the intent? So intent is to kind of, first of all, find out, is there overlap? Is there something already been done? That's one thing we wanted to kind of get your feedback. And then the second thing is, does it really make sense? Like I think David mentioned that we can start out with the incubation, and then people start experimenting with it while it's in incubation phase. And so that's one
I guess the thing I wonder when you talk about getting an incubation is like what incubators come with prereqs, right? And I think we've encountered this before with some of the other things that we look to incubate. And so like to actually incubate this, what are the implied prereqs or the unspoken prereqs? And for one, it seems like we have no way of like incubating API changes, right? It's not like it's something that you can, so that part of do I accept or offer reclaimable resources, like it's not really something you can incubate without changing the core. But on this individual bulleted list, like, so I guess what I'm wondering is like, maybe you could elaborate on what you view as the prereqs, where if you said, yes, let's incubate this, like what it is that the core project is actually agreeing to support to enable your incubation. And I worry that it's maybe more than we can take right now. But then on this individual roadmap, there are things that do interest me that probably interstellars as well. Like I think having some prediction algorithm for resource usage or general resource estimation techniques would be helpful in making some of the existing code today we have potentially more reliable. But I guess do you have to incubate the whole thing, or are there pieces that?
Well, I think no, we're not. I mean, so we can. That's what I'm this discussion though. I mean, so I don't know. So is that an issue though? Let's say we just want to park the whole thing, the whole code base in incubation. So with that that maybe, but that's what I thought would be very simplistic thing. So let's park it, and then we can keep slicing and dicing and see what we can, from that. Yeah.
That's not how the incubation process works today. Incubation is more about like saying there is this long-term project, but we're not really sure whether this is the right direction, and there is like general buy-in from the community on going in that direction. And at that point, we start with an incubation process, mature the feature or the project or whatever it is, and then move it into the core ecosystem. So here, this feels like this is basically touching the whole system, and there are many different intersections with existing components in the system. And we need to talk all of that in detail. And I feel like instead of approaching it from like, hey, here's the code base that we have implemented and this is awesome and it's solving some use case, let's first like talk about the goals and let's try to prioritize them. And then like, let's see what the right solution is for each one of those goals, and then see whether incubation fits in the agenda for each of those goals. Because like,
definitely, I think that's exactly what we should do, and that's the reason we send out the detailed kind of Word document as well. So maybe that we can use that as a document, and then maybe have discuss all those kind of things in the document itself. That, or what do you propose then? Should we have a follow-on meeting and kind of go over, or what exactly should we do then?
So I'm actually going to. So I'm gonna actually say what I feel the community is working towards now in the near future. And please correct me, Derek, Connor, and everybody else in the call if I'm misinterpreting our goals. I thought like we're prioritizing resource management in this order. The first one is like having like very simple scheduling, basic like priority mechanisms, and simple OR subscription, the way we have like burstable and best effort, and have like a really working CODA model. So we can have a deterministic system. And the next level would be like providing performance guarantees or SLOs for that deterministic system. And then the third level would be, or the third priority would be that of improving utilization. So that would be like more smarter resource estimation techniques for basically improving our overcommit, right? Like instead of just doing overcommit by requests and limits, we're going to opportunistically take some more. And never along the way have we prioritized performance guarantees for best effort pods. Like we really do not even have a viable use case for best effort pods yet. Maybe batch workloads might start embracing best effort, but even that is not clear. And on top of that, we're missing some critical features like doing best effort scheduling in the scheduler, just to like spread best effort pods. Right now that doesn't happen. And we're also missing vertical pod autoscaling. So with vertical pod autoscaling, once that's available, what would happen is this headroom would reduce, because then you would have a component similar to the resource estimator that's like constantly changing the requests and limits for a pod. So the headroom is sort of like taken away, and you automatically like get better utilization because you're no longer having pods that are holding it unless you somehow let those pods into your system. So I feel like in terms of biggest bang for the buck, getting the basic performance optimization features we are doing now with like CPU pinning and probably NUMA in the future, and enabling vertical pod autoscaling would like get us towards our goal before we have to do something that's a little bit more drastic to the system, like what's being described in this proposal. And the other thing of like saying quas controller would be outside of the kubelet is something that we already considered in the recent past. Like Connor and Nicholas actually did that whole prototype, and we dropped that idea primarily because we wanted the kubelet to contain the core logic of like figuring out which resources would be assigned to what pods. And we also decided that CPU and memory would be core resources that the kubelet would handle. So like trying to take that away and like reverse the decision is like going back to square one.
Oh, this is regarding the pipeline design.
Correct. So in one of your slides, you're mentioning that this, I think you also got feedback from sig-scheduling that the QoS controller should be part of the kubelet. I mean, we all like as a community, we talked about this quite a bit, and then we came to the decision that kubelet would be the one that is managing CPU and memory, including like overcommitting it. And even if there's some resource estimation aspects of it that could be dealt with by the kubelet itself, because it's necessary for vertical pod autoscaling anyways. So like trying to plug that out is not something that we are looking to do in the near term, because we have a bunch of other priorities.
So the scope for this is the resource reclamation thing. So I understand that. So you're saying you're trying to kind of mitigate that, by doing vertical scaling, vertical part scaling, and all that. So is that something could this become incubation for that? Incubation place for that? The overarching kind of resource utilization gains, using resource reclamation, because this is exactly what we have done essentially. We showed the numbers as well, so from that perspective, overall kind of a resource reclamation perspective.
So I guess my struggle a little bit is it's very focused on just running one class of jobs, best effort jobs, and at least I can speak for at least my user and customer community I have insight into, where today best effort jobs are not really the commonplace, and I feel like there'd be a lot of other prerequisites I'd want in place before it would become the common. We've done some stuff in the last 6 months around enforcement of node allocatable for CPU and memory that can make maybe the appeal of running best effort jobs more practical. But then there are still other things that best effort jobs can cause havoc on, that like the benefits of getting CPU or memory reclamation are outweighed by the other things they can do to destroy your nodes. So for myself, at least, the challenge of making more CPU available for scavengers to complete tasks is not like a high priority for me, at least. I don't know for others, but that's where I am at this point right now, I guess.
I have a basic question. So how is this work related to auto scaling? Do you have any kind of auto scaling support in Kubernetes?
So it's being prioritized over time. Like hopefully it'll be a higher priority soon, maybe in the next release. The thing is, like, there's a feature that's being discussed called vertical pod scaling, and one of the ideas there is that the node could do auto scaling reactively. And then the node can decide how much more resources or how much less resources it has to give for a pod. And that's sort of like resource estimation, right? Like you're trying to predict how much this pod would use. And either you can take the rest away and give it to someone else, or you can just take the rest away and like put it back in the scheduling pool and let someone else use it. But when it comes to the thing that doesn't solve is trying to provide performance guarantees for best effort pods, because during schedule time, you don't know how much best effort pods are going to consume. So you're going to just like try to do some best effort scheduling. And then if you want to guarantee performance for them, that's when like this resource estimation would matter. But so what Derek is saying, my understanding is like there is really no clear use case for best effort pods yet. So this is way ahead of its time, essentially.
Yeah.
The community needs to catch up with trying to improve utilization in Kubernetes by running more best effort workloads.
Or more specifically, what is the workload that's safe to run today as best effort on the cluster that the community can speak to, right? Like, it's not clear to me what your actual workload was when you were running this, when you collected the data, which is why I asked, like, was this like a production thing or an academic thing? Like, is it a very particular workload that was running as a best effort job? Like, what did your batch job do? Did it compute prime numbers, or did it do something more, did it consume disk? Like, what in particular did it do? What class of best effort job was safe to use that this benefited from?
Yeah, Derek, can I suggest that we should take this, continue this discussion there are like multiple email threads, and there's also a doc. Should we just continue it there? I thought like there's one more agenda item today.
Yeah, I'm sorry, and I should have time blocked that, but I understand the what was being presented far better than what was being discussed, and I kind of echo Vish in that I don't know if just saying yes, we'll create an incubator is the right answer because the scope is much larger. I am interested in seeing if we can tease out parts of the solution and maybe grow those without having to take the entire thing. And so we should have some follow-up on that.
Yeah, specifically, the resource estimation parts could be reused for vertical power scaling in the node. That's one concrete thing I can think of right now.
Okay. So, yeah, so I think it'll be great if you folks, I think these are very good comments and feedback, actually. It'd be great, if you can provide that feedback in the document itself, then we can, we have everything in one place, and then we can definitely get back to you folks. And if you want to do a follow-on meeting, we can do that as well to kind of, talk more in detail about certain things. But,
so I already provided this feedback in an email thread that you started. I think Clayton was also responding to that. There are several email threads about this, so I don't know which is the right one to respond to. I can copy and paste my response to other threads.
Oh, okay.
Or I can add this work group to that existing meeting thread.
So, no, actually, I don't think we received. Rohit, did you receive the email? Or if you can maybe resend that email to us, that'd be great.
Okay.
So your email was based on the document which you sent out, your feedback on the document which we sent out?
Yeah, it's like, do you have other colleagues who are working on this? I see someone.
No, it's the same set of people. Yeah.
Oh yeah, I do see here Rohit, Kevin, Ding, and like I'll forward it to this. Right?
Yeah, please.
So I think Fish, your feedback was very broad. I think we can give some more specific feedback, like we discussed here, which is like, what is the workload that you're running that actually benefited from the reclaim, and kind of tease that out because right now it wasn't clear. But that said, I do think we should time box this, and I'm sorry, Nicholas and Connor, that you had another agenda item that we're 20 minutes over on. Is it worth discussing a preview of your topic in the next 10 minutes?
Yeah, sure. We could do just a quick taster, and then maybe bring it up at the next week's.
That sounds good.
So yeah, just I guess the goal was to try to get some consensus on whether people think that that it's a. Okay, so I'm just going to back up. Sorry. So right now we've got a few components that have been implemented and some others that are planned that all make policy decisions that relate to NUMA. So specifically, we're looking at the container network interface plugins, the CPU manager, which is making decisions about core pinning, the device manager. I'm not sure if that's exactly what it's going to be called in the POC, but essentially the component inside the kubelet that makes the concrete device bindings, and also the huge pages C group controller settings. And so I guess the TLDR for describing the problem is that if they're all making independent policy decisions about the specific bindings, and there's no centralized way to unify that affinity, then we could end up, straddling sockets in a bunch of really bad ways that kind of, limits the usefulness of actually all of those components that are trying to increase performance by assuring some sort of NUMA affinity, if that makes sense. And so specifically, you could be pinned to a core and then assign huge pages on another socket, or a NIC on another socket, or if you're connecting to your accelerator hardware over PCIe, you want to be on the same socket that PCI switch is attached to. So I guess the short-term goal is just to maybe get just some sort of agreement within this group that that's a problem that we want to solve in the future, and start a discussion thread about it.
Yeah, that's what you're describing is probably a future bug, and I'm glad that you bring this up. like one of the reasons for trying to unify all of this logic underneath the container manager is to avoid the situation. So, I mean, we should like come up with a practical modular design inside the container manager that will let us like do CPU and memory assignment along with device assignment in like a unified fashion.
And I think what we can present next time is a small spike that we did where we took like a look at maybe 3-4 different ways. But you know, the biggest thing for us, I think, was just to get a feel for people's like, since maybe it's not a sense of urgency, but just like starting a maybe a feature request. So like, you know, in Kubernetes 1.11 or something, that you have NUMA awareness being a line item.
Sure. We should also like touch base upon the work we have planned for 1.8 and 1.9. Like my main concern is like, yes, we definitely need this. It's just that we should not lose focus on the things that we're doing for 1.8 and 1.9.
Certainly, I think one aspect of this is also that just to have this in mind when we design the current components, so we don't shoot ourselves in the foot later on. I think that is maybe why it'd be worthwhile just like doing a thought experiment on it now.
Yeah, that's fair.
Right, Connor?
So I've been thinking for a while, like to have a kubelet architectural chart, like describing the different components. Maybe we might want to have one for the container manager too, that describes what the different modules are and what each of their responsibilities are and how they interact with each other.
Oh my God, Vish, you have me laughing because I remember asking, we should build that, and you said the code's self-evident. It's a roadmap. It's a map. It's very clear.
But now, like a lot of people are, people are asking me the same question that like it's not putting it on. Like the code base is becoming relatively stable now, and we're mostly implementing features and not like moving things around too much.
Yeah.
So I guess anyway, that was the preview version. If we want to stop on time, but maybe come with lots of ideas for next time.
Just to build on what you said, Connor, in terms of accelerators and mostly GPUs, I've got 3 or 4 cases where you can make performance go very wrong. So I think if you're interested, I can share those on documents.
Yeah, that's that, but also just like a quick note to what you said, Vish, for the 1.8 stuff, is that something we should discuss next week or schedule like a special meeting on how we can help accelerate the 1.8 pieces?
Yeah, definitely. I think that'll be helpful if we can like every alternate week or something, if we can have a status update on all the 1.8 stuff that as a group we are working towards. That might necessary.
Yeah, one thing I was thinking, and I know some other SIGs do this too, is maybe we can dedicate time just to doing design reviews for the proposals that might be out in 1.8. If not next week, then plus 1 week beyond that. And just ensure that maybe we alternate meetings to discuss the designs before talking about some of these feature issues. But I know Federation was doing that some, but other SIGs were doing similar. We could try to.
I can also like try to invite any other SIG leads who might be like stakeholders in some of the features we're working. That way, like we do it once across different SIGs.
Yeah. Okay. Well, looks like we will do the brainstorming for next week. And thanks again, Deepak and Rohit, for presenting. And
thanks everybody for letting us present it. Thanks, I appreciate it.
Yep. And I will upload this later on YouTube, and I'll talk to you all soon. Bye, guys.
Thanks a lot. Bye-bye.